Welcome to our deep dive today. I know you're eager to understand Albert Einstein better, and wow, you've given us a lot to work with. Biographies, scientific papers, even some personal letters.
It's quite a collection.
It is. And honestly, having you here, expert speaker, makes me even more excited to dig in. I was thinking we could start with Einstein's early life. See what shaped his thinking, then move into those groundbreaking scientific contributions, and finally explore his impact on the world beyond physics. What do you think?
Sounds like a plan.
Perfect. Okay,
Right.
so we're talking about one of the most famous minds in history. But did you know that Einstein actually failed his first attempt at getting into the Zurich Polytechnic School?
It's true. And I think it really challenges that myth of the straight-A genius.
Mm-hmm.
Einstein excelled in math and physics. He was teaching himself calculus at 12. Even came up with his own proof for the Pythagorean theorem at age 12.
Wow.
But languages, not his strong suit.
So it wasn't a lack of intelligence, but maybe more like how he learned best?
Exactly. Different minds work in different ways. It's interesting to think how this unconventional start might have influenced Einstein's later willingness to challenge established scientific thought. Maybe those early academic struggles fostered a sense of independence in his thinking.
That's fascinating. Makes you wonder if his path would have been different, if he just sailed through traditional schooling.
It does. But even with those hurdles, his brilliance was evident early on.
Right. And it wasn't just from textbooks. I was reading how his father, when Einstein was 5, gave him a compass while he was sick in bed.
A simple gift. But in Einstein's own words, it sparked a lifelong fascination. He realized there were unseen forces at play, something deeply hidden, he said, behind everyday objects.
That's a great anecdote. And then around 13, a family friend, Max Talmud, introduced him to philosophy, even Kant.
That's a key influence often overlooked. Kant emphasized reason and questioning assumptions. It makes you wonder how that philosophical foundation might have shaped Einstein's scientific approach.
Almost like planting the seeds for his later groundbreaking work. Okay, so fast forward a bit. Einstein does eventually get into Zurich Polytechnic, where he meets Mileva Maric.
Right.
There's a lot of debate about her contributions to his early work, right?
There is. Some argue she played a substantial role, others downplay it. But regardless, their letters reveal a shared intellectual passion.
Bouncing ideas off each other, engrossed in those big scientific questions.
Yeah.
It really humanizes the process, right? It wasn't just Einstein alone in a lab. It was this collaboration fueled by passion.
Precisely. And that human element often gets lost, in the telling of scientific history.
Okay, let's talk about those mind-blowing scientific contributions. I know we can't cover everything,
Right.
but we have to touch on the Annus Mirabilis papers. 1905, 4 revolutionary papers in a single year. That's unheard of. What was so groundbreaking about them?
Well, one was on the photoelectric effect, explaining how light can act as both a wave and a particle. This introduced the idea of photons and completely changed how we understood light itself.
Light as a particle, it's hard to wrap your head around that.
This work eventually won Einstein the Nobel Prize in 1921.
And that was just one paper.
Right. Another tackled Brownian motion, the seemingly random jiggling of particles in a fluid. Einstein showed this was due to collisions with the fluid's molecules, essentially proving the existence of molecules, which back then was still a matter of debate.
So he was confirming the building blocks of matter.
Absolutely.
That's huge.
And then there's his paper on special relativity, where he proposed that the laws of physics are the same for all observers moving at a constant speed, and that the speed of light in a vacuum is constant for all observers, regardless of the speed of the light source.
So speed is relative except for the speed of light, which is always constant. Did I get that right?
Exactly. This idea completely challenged the foundations of Newtonian physics, which had dominated scientific thought for centuries.
I'm starting to see why 1905 was called a miracle year.
And let's not forget, the famous EMC immensi derived from his work on special relativity. This deceptively simple equation showed that energy and mass are interchangeable, forever linking these two fundamental concepts.
It's incredible to think that all these ideas, which are still taught and studied today, came out in such a short span of time. It makes you wonder what sparked that burst of creativity.
It's truly remarkable. And it was just the beginning. Just a few years later, Einstein began developing his theory of general relativity, which incorporated gravity into his earlier work on special relativity and introduced the concept of curved spacetime.
Curved space-time. I have to admit that one always sounded a bit like science fiction to me. It's not like you can see space-time bending, right?
It's definitely mind-bending, but there are ways to visualize it. Imagine a bowling ball placed on a trampoline. The ball creates a dip, right? That's kind of what massive objects do to spacetime. They warp it, and this warping in what we experience as gravity.
So gravity isn't a force pulling objects together, but rather a curvature in space-time caused by those objects.
Precisely. And the remarkable thing is that this wasn't just some abstract idea. Einstein's theory made testable predictions about how light would be affected by this curvature, particularly light, passing by a massive object like our sun.
And that's where the famous 1919 solar eclipse comes in.
Exactly. During the eclipse, scientists were able to observe the apparent shift in the position of stars near the sun, and the measurements matched Einstein's predictions almost perfectly.
That must have been a monumental moment for him. It wasn't just a theory anymore, it was proven.
It was a defining moment. That confirmation made Einstein a global celebrity almost overnight. He was hailed as a revolutionary who had rewritten our understanding of the universe.
From struggling student to scientific superstar, all thanks to a mind that dared to question everything. But even with all this success, Einstein wasn't done. He also made important contributions to the development of quantum mechanics.
Oh, absolutely. He did groundbreaking work on photons, quantized atomic vibrations, even the Bose-Einstein condensate.
Okay, you're going to have to explain that one a bit more. Bose-Einstein condensate. It sounds a bit like something out of Star Trek. What is that?
Imagine a state of matter where separate atoms, cooled to near absolute zero, begin to occupy the same quantum state, essentially behaving like a single superatom. It's a mind-boggling concept, but it illustrates how Einstein's work stretched far beyond his most famous theories.
So it wasn't just about relativity, he was pushing boundaries in multiple areas of physics.
Exactly. He even laid the theoretical groundwork for lasers with his work on stimulated emission. But his relationship with quantum mechanics wasn't straightforward. He was a pioneer, but later became a critic of its probabilistic nature. He famously said, "God does not play dice," expressing his discomfort with the idea of randomness at the heart of reality.
So even Einstein had his doubts about some aspects of modern science. I guess it shows that even the most brilliant minds are constantly evolving in their understanding of the world.
Absolutely. And this brings us to another fascinating aspect of Einstein, the man beyond the science, his engagement with social and political issues. I think that's where we should pick up in part 2. What do you think?
I completely agree. It's time to delve into Einstein, the humanist, the activist, the man beyond the equations. Okay, so we've explored Einstein's incredible scientific mind, but as we hinted at, he was so much more than just a physicist. Looking at all this material, his humanitarianism really shines through.
It does. He was a vocal pacifist, especially during World War I. Later, he became a strong advocate for a world government, as a way to prevent future wars.
A world government seems like a pretty radical idea. What led him to that belief?
Well, it was connected to several things. His own experiences with rising nationalism in Europe, and he also drew a parallel between his views on pacifism and his support for Zionism.
That's interesting. How did those two connect for him?
He saw both pacifism and Zionism as ways to address conflict and injustice on a larger scale. He believed the creation of a Jewish state was necessary to provide a safe haven for Jews who had faced centuries of persecution.
Makes sense, especially considering his own experiences with anti-Semitism.
Exactly. But it's important to note that his support for Zionism wasn't without nuance. He initially opposed the idea of a separate Jewish state, favoring Arab-Jewish coexistence in Palestine instead.
So even in his advocacy, he was searching for peaceful and inclusive solutions. He wasn't interested in just replacing one form of nationalism with another.
You've hit the nail on the head. And this commitment to inclusivity and equality extended to his views on race relations in America as well.
Yes. His activism against racism, particularly his work with the NAACP, was something that surprised me when I was going through all this.
It's a side of Einstein that's not always highlighted, but it's incredibly important. He saw firsthand the deep-seated racism in American society and was appalled by it.
It wasn't just theoretical for him, it was something he encountered directly. There's that famous story about his friendship with Marian Anderson, the African-American opera singer. She was denied a room at the Nassau Inn in Princeton, and Einstein invited her to stay at his home.
It was an incredibly powerful gesture, both personally and symbolically. It showed that his commitment to social justice went beyond words. He was willing to use his platform and his personal resources to fight for what he believed in.
And it wasn't just a one-time thing. Anderson actually stayed with Einstein whenever she returned to Princeton. Their friendship speaks volumes about his character.
It does. He didn't shy away from taking a stand, even when it was unpopular.
Speaking of taking a stand, we can't talk about Einstein without mentioning his involvement in the discussions around nuclear weapons.
Yes, that's another complex and often debated aspect of his legacy. His famous letter to President Roosevelt in 1939, urging the U.S. to develop its own nuclear research program, is a key part of that story.
It's a decision that seems at odds with his pacifist beliefs. What motivated him to write that letter?
At the time, the threat of Nazi Germany acquiring this technology was very real. He and many others believed that the potential consequences of a Nazi atomic bomb were just too dire to ignore.
So it was a decision driven by a sense of urgency and the potential for catastrophic consequences.
Exactly. But it was a decision he grappled with later, especially after witnessing the devastation caused by the atomic bombs dropped on Hiroshima and Nagasaki.
It must have been incredibly difficult for him knowing that his actions, even if well-intentioned, contributed to such a tragic outcome.
It was a heavy burden. He saw the destructive potential of nuclear weapons, and he dedicated much of his later years to promoting peace and disarmament. He became a vocal critic of the nuclear arms race and advocated for international control of atomic energy.
Almost seems like he felt a personal responsibility to counteract the destructive power he had helped unleash.
I think that's a fair assessment. The development and use of atomic weapons clearly weighed heavily on his conscience.
It's a sobering reminder of the unintended consequences that can stem from even the most brilliant scientific discoveries. It also speaks to the importance of ethical considerations in scientific pursuits.
Absolutely. The story of the atomic bomb is a stark illustration of how scientific progress can be both a source of hope and a cause for profound concern. It's a reminder that we need to be thoughtful about the potential consequences of our scientific endeavors and to engage in open and honest discussions about the ethical implications of our work.
I couldn't agree more. Now, before we move on, I have to ask about something that struck me while I was reading through his letters. Music clearly played a huge role in Einstein's life. He was a skilled violinist, played regularly. Do you think music was an escape for him from these weighty issues, or even a way to kind of process them?
That's a great question. Music was clearly a depth source of joy and solace for Einstein. He even said that if he hadn't been a physicist, he probably would have been a musician. There's a story about him playing with the Gilead Quartet near the end of his life, and they're apparently quite impressed with his musical abilities.
So it wasn't just a casual hobby for him, it was something he was quite passionate about.
Precisely. I think music provided him with a way to connect with something larger than himself, to experience beauty and harmony in a world often filled with discord. It may have been both an escape and a way to process the complex emotions he was wrestling with.
It's a beautiful image, Einstein finding solace and inspiration in music. It reminds us that even the most brilliant minds need outlets for creative expression and emotional release.
Absolutely. And it speaks to the interconnectedness of different aspects of human experience, science, art, social justice, personal reflection.
Okay, I think we've explored Einstein's life beyond physics quite thoroughly. Before we move on to his lasting legacy, is there anything else you think we should touch on?
I think we've covered the key points. We've seen Einstein the pacifist, the advocate for social justice, the conflicted participant in the nuclear age. It's a multifaceted portrait of a complex and fascinating individual.
I agree. It's been a truly enlightening journey so far. Ready to move on to the final part of our deep dive?
Absolutely. Let's explore Einstein's enduring impact on the world.
It's incredible, isn't it? We've seen Einstein, the groundbreaking scientist, Einstein, the humanist and activist. Almost hard to believe it's all the same person.
It is remarkable. And even though he's been gone for decades, Einstein's influence is still so deeply felt.
Absolutely. His ideas continue to shape scientific research, and his image, it's become an icon of intellectual curiosity and genius.
It's true, but I think to really understand his legacy, we need to go back to some of the scientific concepts we touched on earlier.
You're right. I have to admit, some of those papers, they were pretty challenging. I felt a little like I was back in physics class, trying to wrap my head around things like curved space-time and quantum mechanics.
Well, even for seasoned physicists, Einstein's work can be mind-bending. But it's that very complexity that makes it so fascinating. He was wrestling with some of the most fundamental questions about the nature of reality.
I guess that's what makes him such an enduring figure. He wasn't afraid to tackle those big unanswered questions.
Exactly. And one of the areas where this is most evident is his engagement with and eventual skepticism of quantum mechanics.
Right. He was a pioneer in the field, but then became one of his most famous critics. He couldn't quite reconcile himself with the idea that the universe might be governed by chance.
You're remembering his famous quote, "God does not play dice." It highlights his discomfort with the inherent randomness and uncertainty at the heart of quantum theory. He believed there had to be some underlying order to the universe. Things couldn't just be random.
So even though he helped develop quantum mechanics, he wasn't fully convinced by it.
He wasn't. This belief led him to engage in a series of thought experiments and debates with some of the other leading physicists of the time, like Niels Bohr, trying to poke holes in the theory or find a way to reconcile it with his own understanding of a universe governed by laws, not chance.
So even though he was a Nobel laureate, he wasn't afraid to challenge the prevailing scientific wisdom, even his own.
Exactly. And these weren't just abstract philosophical discussions. They had real-world implications for the development of physics.
Can you give us an example?
One of the most famous debates centered on the concept of quantum entanglement. This is where two particles become linked in such a way that their properties are correlated even when separated by vast distances.
Okay, that one still makes my head spin a little. How can two particles be connected like that when they're miles apart?
It's definitely mind-boggling, and even today it's not fully understood. But Einstein saw this spooky action at a distance, as he called it, as evidence that quantum mechanics was incomplete. He believed there must be some hidden variables, some underlying mechanism that could explain this seemingly impossible connection.
So he was suggesting that there was more to the story than what quantum mechanics was currently able to explain.
Precisely. He believed that a more complete theory would eventually be developed, one that could account for both the observed phenomena and his deep belief in an underlying order of the universe.
It's amazing how his intuition and willingness to challenge the status quo led to such profound insights, even if he didn't necessarily have all the answers.
Indeed. And while he didn't live to see a resolution to this debate, his work on entanglement has had a huge impact on the field of quantum information theory, which is a rapidly evolving area of research with potentially revolutionary applications.
So even his skepticism about quantum mechanics ended up shaping the future of physics.
Absolutely. And this ties into another key theme that runs throughout Einstein's scientific career, his relentless pursuit of a unified field theory.
Right, we haven't talked much about that yet. Can you explain what a unified field theory is and why it was so important to Einstein?
Essentially, it's a theory that attempts to describe all the fundamental forces of nature within a single framework. So instead of having separate theories for gravity, electromagnetism, and the strong and weak nuclear forces, a unified field theory would bring them all together, demonstrating their interconnectedness.
So he was searching for the ultimate equation, the one that could explain the workings of the entire universe.
That's a great way to put it. He believed that such a theory must exist, and he spent much of his later years searching for it, trying to find the underlying connections between the seemingly disparate forces of nature.
Did he ever succeed? Did he find that one unifying theory?
While he made significant progress and laid the groundwork for future research, he didn't achieve his ultimate goal of a complete unified field theory before his death. However, his efforts continue to inspire physicists today, particularly in areas like string theory and quantum gravity, which are still grappling with this challenge of unification.
It's amazing to think that even though he wasn't successful in that particular quest, his vision still drives scientific research today.
His legacy extends far beyond any single discovery or theory. It's about his approach to science, his relentless curiosity, his willingness to challenge assumptions, his belief in the power of human reason to unlock the secrets of the universe.
Well said. It feels like we've only just scratched the surface of this fascinating man. What would you say is the most important thing for our listener to take away from our deep dive into the world of Albert Einstein?
I think it's the reminder that genius is not just about innate intelligence, but also about hard work, dedication, and a willingness to be wrong, to question, and to never stop learning. Einstein's life shows us that the pursuit of knowledge is a lifelong journey full of twists and turns, doubts and discoveries.
I couldn't agree more. And who knows, maybe listening to this has sparked that same kind of curiosity in you, our listener. Maybe you'll be the one to solve the mysteries that Einstein dedicated his life to exploring.
That's a wonderful thought. The world needs more curious minds, more people willing to challenge the status quo and push the boundaries of human understanding.
Beautifully said. I think that's the perfect note to end on. Thanks for joining me on this incredible deep dive expert speaker. It's been an honor. And to you, our listener, thanks for listening. We hope this has inspired you to keep asking questions, keep learning, and never lose that sense of wonder about the world around us.